Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is maximum eraser value. Now, the problem category is of medium level, but I would say this is actually an easy problem. We just need to understand few concepts about two pointers and then try to solve the examples on paper. If you know about two pointers, try to solve the examples on paper. You will find this problem very easy to code as well. Now, the input given in the problem is an integer array nums, and the output we need to give is the maximum sum we can have for a particular subarray in our integer array nums with unique values. Now you might have read a different thing in the question. The question says that you are given an array of positive integer nums, we know about it in the input, and we want to erase a subarray containing unique elements. So suppose you have an array, right? And we want to erase a subarray from this array which has unique elements. For example, this is a subarray 4 and 5. We want to erase it out of our array because it contains unique elements only 4 and 5, right? Now we want to find the score of this erased array, and the score is the sum of each of the elements. So in this particular array, if I'm erasing a particular subarray 4 5, the sum of this subarray is 4 plus 5, that is the sum of each of the elements, which is equal to 9. So basically for this subarray which has unique elements, the score is 9. Now the question says that return the maximum score you can get by erasing exactly one subarray. It is a very bad descriptive question, I would say. The thing which you will need to understand is the output you need to give is basically you need to find a subarray from your array which has unique element, and then find the sum of the subarray, that is the sum of each element of your subarray. You want to find that subarray which can give me the sum as max value. That is, find the sum of a subarray with unique values, and this sum should be maximum. You should try to find that subarray which can give me the maximum sum, right? So I would say this is the complete question all about. Now let me try to explain it with some examples. So in the example number 1, let us say the given array is 4, 2, 4, 5 and 6. Total 5 elements are given. And the thing is, guys, what is a subarray? If you are confused about what is a subarray, basically in your array, any continuous set of element can be called as a subarray. For example, the whole array is also a subarray because each elements are continuous. 4, 2, 4, 5, 6, right? I can also say 2, 4 and 5 is a subarray because the elements are continuous. We have 2, then 4, then 5, right? But 4, 2 and 5, that is 4, 2, 5, this is not a subarray because the elements are not continuous, right? We have 4, then 2, but then we have a 4, but in our subarray, we are taking 5, right? So that is basically a subarray. Any continuous set of elements from your array is called a subarray. Now, for this particular example, the output is 17. That is, for this particular example, we have a subarray from this array such that that subarray has unique values, and the sum of the elements of that subarray is 17. Now the thing is, since we need to maximize the value, right? We have to maximize the value, we have to maximize the sum. So we have to take a subarray which can give me the maximum sum, right? Now if I ask you, forget about unique values, try to find out the subarray which has the maximum sum, then there is just one answer. The whole complete array is also a subarray. I can take the complete array as the subarray, and then I can take the sum of each of my element. We have 4 plus 2 is 6, then 4 10, then 5 15, then 6 21. So our answer would be 21. But since our subarray as of now is having duplicate values, I have 4 here as well as 4 here, right? The question says that you have to find a subarray with unique values only, right? So what I can do is I can take this particular subarray, ignore the 4, take this particular subarray, 2, 4, 5, 6. All my elements are unique, right? I don't have any duplicate values. The sum is 2 plus 4 is 6, then plus 5 is 11, then plus 6 is 17. That's the output, right? Now there is another subarray which has unique elements, which is 4, 5. This is a subarray. It has unique elements, but the problem is the sum is 4 plus 5 is 9. We need to maximize the sum, and that is why we had taken this particular subarray, and the sum is 17. 2 plus 4 plus 5 plus 6. In the example number 2, the output is 8, and that is because our subarray is 5, 2, 1. This is a subarray from our complete array which has all unique elements, 5, then 2, then 1. The sum is 5 plus 2 plus 1, which is 8. Now you cannot find any other subarray in this particular whole array such that the sum of the elements in that subarray is more than 8. And that is why the output is 8 here. Now how can we solve this? Now remember guys, I told you about two pointers. If you know about two pointers, and if you can solve this particular problem on paper, not with code, on paper, then you will come to know about the solution, the coding solution of this problem as well. So let us try to do it. As of now, our complete intuition is, let us try to solve the problem on paper. As of now, we don't know about two pointers. This is basically an algorithm to solve questions like this. But let us say we don't know about two pointers. We just know that this is an example and we need to solve it on paper. Now my approach will be, let me select the first element. Let us say 5 is my subarray. Alright. Now let me add one more element, which is the next one, 2. As of now, my subarray is having unique elements, 5, then 2, right? Let us take 1 as well, right? Let's take 1 as well. Alright, 1 is fine as well. I can take 1 because now my elements have 5, 2 and 1. All are unique. Now I get a 2. Can I add a 2 here? No, because this 2 is already in my element list. I already have seen this particular 2, right? Now this is a subarray. Now my subarray cannot have one more 2 in it. So from here I can say that I got a subarray. That subarray is 5, 2, 1, and the sum of this subarray is 8. What we can basically do is when we see 5, my sum will be 5. Then when we see 2, my sum will be 5 plus 2, which is 7. Then when we see 1, my sum will be 7 plus 1, which is 8, right? Now when we see 2, since we have already seen a 2, now we cannot add this 2 in our subarray. So we got a subarray which is 5 to 1, which has a sum of 8. As of now, no coding involved, no extra thought process. Everything is going just on paper without any extra thought process, right? Now, if I ask you that your current subarray is 5 to 1, you try to add 2, but now you came to know that 2 cannot be added. Now, if I ask you programmatically, how can you find 2 cannot be added in your current sub array? How can you find this? See, one of the ways you keep track of your elements that, okay, as of now I have 5, then 2, then 1 in an array or a list. So now you have a list which has 3 elements, 5, 2, 1. You have to search for the next element, that is this element already in your array? Yes, it is already in your array. You can just run a loop and then you can see, okay, I got this element. But this running of loop is one process. A better process is set, right? In set, searching for a particular data is done in just one operation. You don't need to run a loop. It can be done in O of 1, right? And that is something which we need to understand. This is something which we need to know. This intuition cannot be built if you don't know about the concept that in set, you can store your elements and search for an element in just one operation in O of 1 time complexity. So what we can do is, we can have a set, right? We can have a set and we can say, okay, I got a 5, I got a 2, I got a 1, right? My next element which is coming is 2. Is this 2 already in my set? Yes. It means now my subarray cannot be 5, 2, 1, 2 because this 2 is already in my subarray. At this point, my current sum is 8. That is my maximum sum I have got as of now. Alright, this is my maximum sum. But maybe I have another subarray in this array which has a sum more than 8. We don't know as of now, right? So what we can do is we can say, okay, this new element 2 is telling me that I have to create a new subarray. But what will be the starting point of your new subarray? Now forget about programming. If I ask you normally, what will be the starting point of our new subarray when we have this 2? Then you will say that, okay, since we have seen a 2 here, we cannot take elements till this point, right? We cannot have 5, we cannot have 2 in our subarray, but we can have 1 and then we can have 2, right? Now my new subarray can have elements like 1 and 2, right? As of now, the best answer which I have got is 8, right? This is the answer I have got, the sum of the elements of subarray. Now, this subarray is done, 5, 2 and 1. I want to create a new subarray which will have the element 2, but I don't want to start from 2. The reason is I need to find the maximum sum. So I can include this 1 as well, because if I include this 1 in my subarray, that is my current subarray is 1, 2, that is this particular subarray, right? So there is no problem because the elements are unique, right? The elements are not repeating. So this is our new subarray, 1, 2, nothing as of now because we have to see more elements now. But when you will see the new element 5, as of now the sum of my subarray is 3. I will tell you how can you find this programmatically, how can you think about finding this programmatically, but as of now think about this. You have this subarray, the sum is 3. Now there is a new element which is coming in. When you will check it programmatically, you will say, okay, I want to insert this 5 in my sub array. This sub array 1, 2, 5 is valid, right? It doesn't have any unique elements, so it is valid. But when you will try to insert this, or when you will try to track this particular 5 in your current sub array, programmatically what you have to do is you have to check that does this particular element belong to my set? Yes, this 5 is there in my set. So there is a problem, right? This particular sub array is fine. This 5 should not be in our set now. That is because now my sub array is starting from 1 till 2. Then we try to add 5. And that is because we started with 5, inserted 5 in our set, then 2, then 2 in our set, then 1 in our set, then 2. But this 2 is already in our set. It means that we cannot have this 2 along with these elements, right? But we can have this 2 after this 2, right? After this 2, we have a 1. So we can have a sub array starting from 1 and 2 because this should be fine. It has unique elements. So the thing is, the moment you find an element which is already in my set, I will try to delete all those elements which are till 2. I will try to delete 5, delete 2 from my set, so that now my set is having just one element which is 1, right? I have just one element and this is 1, which should be correct because now our subarray is starting from 1, then it will have 2 inserted in the set, then it will have 5 inserted in the set, right? Then the 2 will be coming and we will have a match again. But as of now, what we have to do is we will say, okay, as of now, my sub array was starting from 0 index up to 2 index. Now my sub array will start from index number 2 and it will go till, let us see what, till what point. So what we will do is we will create two pointers. There will be a pointer left which will be 0, then there will be a pointer right which will be 0. Then what we will do is we will say, okay, my left pointer is 0, right pointer is 0, it means our subarray is 5. Let me put this 5 in the set, then increase the right pointer. It is pointing to the element 2 and the value is now 1, index 1. Let me put the 2 in my set, then my right pointer will be 2 which is pointing to 1. So this is my right index which is at point number 2 or index number 2. So left is 0, right is 2. Now when we try to move our right to index number 3 instead of 2, we got a match. So what we will do is we will move our left pointer to the index which is just after the previous 2, so that our new subarray can be from index number 2 to index number 3 as of now, which will have unique elements. But how can we do this? What we will do is we had our left here, right, at 0. We will remove 5, we will remove 2. So what we will do is we will say, okay, let me try to remove all those elements which are till the point 2, till the number 2. So total we are removing 2 elements. So our left index is moving 2 points, right? And we are removing 5 and 2. So we will remove this 5 and 2. And now our subarray will have 1 and 2 in this. We will have this 2. And the moment we have this 2, we will add this 2 in our set again, right? Then we have a 5. We don't have a 5 as of now. We just have 1 and 2. So we will have this 5 and we will insert 5 in our subarray, right? As of now, the sum is 8. Now we got the 2 again. So since we have the 2 again, now we will move our left pointer here just after the previous 2, so that now we can start creating the subarray from this point. But now we will remove the 1 and 2 from our set again. We will remove this 1, we will remove this 2, and our set is having this 5 now, and then we will have this 2 here. But the thing is, we had this subarray 5 to 1, then we created another subarray 1 to 5. Both have the same sum. The sum is 8, right? If the sum is 8, then we can say our maximum sum as of now is 8. Now our new subarray is starting from 5, then it is 2, then it will be 1, then again 2 will match, right? Then again we will start from 1, then 2, then 5. So this is the usual process we will follow. So we are basically using two pointers to solve this particular problem, and I will tell you how. There will be two pointers, a pointer left, a pointer right. So let us say there is a pointer left and then there is a pointer right. So as of now the subarray is 5. Then we move our right pointer here and we say that our subarray is now from 5 to 2, which is fine. Then we again move our right pointer and we say, okay, now our subarray is this 5 to 1, which is fine. The sum is 8 as of now. Now we again move our right pointer and we say the sum is 5 2 1 2, 5 plus 2 plus 1 plus 2. But the problem is, before we actually calculate the sum, that we got a repeating element, right? So we got a repeating element, the element is 2. Since this is the repeating element, right? So now we can move our left pointer here, right? So now our subarray is this one, 1 comma 2. Then we can move our right pointer, right? Then we move our right pointer again. Again there is a match. We have this 2 here, we have the 2 here, right? This is our subarray. So there is a match. So let's move our left pointer. We are basically using two number of pointers, left pointer and right pointer, to solve the particular problem. And that is why I told you, solve the problem on paper. But if you know about two pointers algorithm, you will find the code as well. Now let me get back to the code editor and let me try to show you how the solution for this particular problem looks like. So what we are going to have is, we are going to have a left pointer which is 0. We will have a set scene. So we created a set with the name scene. Then the sum of my current subarray and my final result, both are 0 as of now. Then we run a loop for right in the range of length of my num. We run a loop, and then inside the loop we are going to check one condition. Now this condition will not be true for the first time, so I will come back to this condition. First time what will happen is, we are going to add my current element in the scene set. Then we are going to increase the sum of our current subarray, which will be current plus nums of right. Then the result will always be the max of the current result and the current sum. But let us say we actually got our current element, which is nums of right, in the scene set. In this case, we will start removing the elements from the left. We will say, from the scene set, remove the nums of left, and the current sum is going to be reduced, right? Current will be current minus nums of left, and then we are going to increase the left index. We are going to continue this process till we have the element, till we have the duplicate element in our scene set. And this is basically doing the exact thing which we have talked about during the understanding process on the pad. So after this particular loop, our final result is going to be in the result variable, and then we can return the result, submit the particular code, and this is going to pass all the test cases. And this is a very efficient code for this particular problem. So that's it for this video, guys. If this video helps you to understand the problem, understand the solution approach, understand the intuition behind this, then make sure that you hit that like button. And if you are not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this video, guys.